bucka. Ha. You know the deal.
The next thing we're going to talk about in our probability unit is probability. We had to introduce probability by talking about how to come up with the number of possible outcomes, because we need to know how to do that before we can talk about how to calculate probability or how to express probability. So first of all, probability is defined as the likelihood that an outcome will happen. And probability is usually expressed as a fraction. Now, if it can be expressed as a fraction, as we talked about in our percent unit, a fraction can be expressed as a decimal or a percent as well. So probability can be expressed as a fraction, and it usually is, but it can also be expressed as a decimal or as a percent. For the most part, for our purposes, we're going to express probability as a fraction. And when we express probability as a fraction, we have a numerator and a denominator. In the numerator goes the number of favorable outcomes. So these are the outcomes that we want to happen. And in the denominator, we have the total number of possible outcomes, which is what we talked about in the last video. So that's all of the possible things that could happen. So to explore probability, let's look at a couple of examples. First example we're going to look at is flipping a coin. And the question is, what is the probability of getting heads when you flip a coin? Well, we're going to express probability as a fraction, and I'm going to start with the denominator. So in the denominator, we put the total number of possible outcomes. And as we've seen, when we flip a coin, the total outcomes that could happen, the things that could happen, is we could get heads or we could get tails. So that means we have two total possible outcomes, which means in our denominator we have two, because there are two things that could happen in this experiment. Well, we want to know the probability of getting heads, and on this list of all of the possible outcomes, we see we can get heads once. There's one favorable outcome here. So in our numerator we put 1. So the probability of getting heads when we flip a coin, we would express as a fraction, and that fraction would be 1 over 2. 2 goes in the denominator because when we flip a coin, there's two possible outcomes. We could get heads or tails. 1 goes in the numerator because there's only one favorable outcome. Our favorable outcome here is we want to get heads. So the probability of getting heads is 1 out of 2. Well, let's look at another example here. So the next example we're going to look at is, what is the probability of getting an even number when you roll a dice? So just like with the last one, we're going to express probability as a fraction, and I'm going to start with the denominator. So I'm going to start with the total number of possible outcomes, and I'm going to list them here. And all the possible outcomes when we roll a dice is we could get 1, 2, 3, 4, 5, or 6. So we have 6 total possible outcomes in this experiment. So that's what goes in our denominator. Now, our favorable outcome here is we want to get an even number. So if we look at all of our outcomes here, and this is why it's nice to kind of list all of the possible outcomes, I can see that there are 1, 2, 3 even numbers. So the favorable outcomes that we have here is 3. Because there are 3 even numbers on a dice out of 6 possible numbers that we could get. So the probability of getting an even number when we roll a dice is 3 out of 6. Now, just like with any question involving fractions, our final answer has to be in simplest form. When we reduce that to simplest form, we get 1 out of 2. So the probability of getting an even number when we roll a dice is 1 out of 2. Let's look at another example. Suppose we want to know what is the probability of getting just a 5 when you roll a dice. Well, as we've already discussed a couple of times, when we roll a dice, there's 6 possible outcomes. So again, I'm going to start with the denominator here, and that's all of the possible outcomes, which in this case is 6. In the numerator, I want to put the number of favorable outcomes. My favorable outcomes is, well, I want to get a 5. On this list, there's only one 5. So my number of favorable outcomes is 1. So the probability of getting a 5 if you roll a dice is 1 out of 6. Let's look at one more example involving dice, and in this case I want to know the probability of getting a 5 or a 2. Now what I'm going to do to explore this one a little bit is I'm going to look at individually each one of these as favorable outcomes. Well, as we just saw, the probability of getting a 5 is 1 out of 6. And as you probably also understand, the probability of just getting a 2 is also 1 out of 6. Now, if we want to get a 5 or a 2, well, the number of favorable outcomes here is we have a 5 or a 2. That means that the probability of getting a 5 or a 2 is 2 out of 6, because we have a 5 and a 2 on that list. So what you can see here is if you have more than one favorable outcome and you want one or the other, mathematically you can take the probability of one, the probability of the other, and add them together if you want to get one or the other. So in probability, when we see that word or, it usually means that we're adding the probabilities of the two individual favorable outcomes together. Let's look at another example, and this time we're dealing with the spinner. This is a fair experiment when we spin this spinner because the four possible outcomes that we have here are equally likely, and as you can see from looking at the spinner, there are 4 possible outcomes in total. So when we want to know the probability of getting green, well, again, we're going to express probability as a fraction. In the denominator is the total number of possible outcomes, and in this experiment there's 4. We could get green, yellow, blue, or red, and they're all equally likely, so there's 4 total possible outcomes. And the number of favorable outcomes is just 1, because there's only one section that's green there. Similarly, if we want to get yellow, if we want to know the probability of getting yellow, it's also 1 out of 4. There's only one section out of 4 sections. Now, if we want to get green or yellow or blue, well, as we just discussed, to figure that out, one way to do it is take the probability of each one. So the probability of getting green is 1 out of 4. The probability of getting yellow is 1 out of 4. And the probability of getting blue is 1 out of 4. So to figure out the probability of green or yellow or blue, we add those 3 probabilities together. And the probability of getting green or yellow or blue is 3 out of 4. And we can also see that it's 3 out of 4 because there's 3 favorable outcomes. 3 things that we want to get out of 4 total possible outcomes. So once again here we can see that in probability, when you see that word or, you're adding the probability of the individual favorable outcomes. So for this next example, we're going to combine 2 experiments. So here we're going to flip a coin and roll a dice, and we want to know the probability of getting heads with an even number or tails and a 3. So first thing I'm going to do is list all of the possible outcomes when we flip a coin and roll a dice. And this is something that we talked about in the last video, so I'm just going to quickly list them. So we know that we could get heads with 1, heads with 2, and so on. We could get heads with any one of the 6 numbers. Or we could get tails with any of the 6 numbers. So again, as we discussed in the last video, when we flip a coin and roll a dice, we have 12 possible outcomes. 2 possible outcomes if we flip a coin, 6 possible outcomes if we roll a dice. So if we combine these 2 experiments together, the total number of outcomes is 12. So when we're expressing probability as a fraction here, the total number of outcomes is going to go in the denominator, and that's going to be 12. Well, for the first example, we're looking for heads and an even number. So when we're looking for heads and an even number, we're looking for heads with 2, heads with 4, or heads with 6. So the probability of getting heads and an even number is 3 out of 12. Which we would reduce to 1 out of 4. Now, for the second example, again, the total number of outcomes is going to go in the denominator, and it's still 12, because that's all of the possible things that could happen. And now when we're looking for our favorable outcome, well, our favorable outcome is we want tails and a 3, and that's only happening once here on our list. So our probability of getting tails and a 3 is 1 out of 12. Well, with our last couple of examples, we explored that word of with probability. And as we saw, that word of in probability usually means we're adding the individual probabilities together. What we're going to explore here is this word and. So if we look at just flipping a coin, the probability of getting heads, as we've already seen, is 1 out of 2. When we flip a coin, there's 2 possible outcomes. You can get heads or you can get tails, and our favorable outcome here is heads. So that's one favorable outcome. When you roll a dice, if you want to get an even number, the probability of getting an even number is 3 out of 6. There's 6 possible outcomes when you roll a dice, and 3 of them are even numbers. Going down to the second example here, when we flip a coin, if we want to get tails, the probability of getting tails is 1 out of 2. When we roll a dice, if we want to get a 3, the probability of getting a 3 is 1 out of 6. Now, when we look at these fractions and when we put this word and into it, what we can see here is we're taking the individual probabilities and multiplying them together. So the probability of getting tails and a 3 is 1 out of 12. And the probability of getting heads and an even number, well, to calculate that here, we take the probability of getting heads, which is 1 out of 2, the probability of getting an even number, which is 3 out of 6, we multiply that together, and we get 3 over 12, which would reduce to 1 out of 4, which is what we got over here when we looked at the probability of getting heads and an even number by looking at that list. So again, when you see that word and in probability, it usually means you're multiplying the probability of one individual experiment and the probability of another individual experiment, multiplying them together to see what the probability of getting one and the other would be. So let's continue to explore this word and when we combine 2 experiments. So suppose you roll a dice and draw a card out of a deck of 52 cards, and you want to know what is the probability of getting the Jack of Diamonds, that specific one card, and an even number. Well, let's look at the individual probabilities here first. So to get the probability of getting the Jack of Diamonds, we have to know how many possible outcomes there are. When we draw a card out of a deck of cards, there are 52 possible outcomes, and there's only one Jack of Diamonds in a deck of cards. So the probability of getting the Jack of Diamonds is 1 out of 52. The probability of getting an even number when you roll a dice is 3 out of 6, which reduces to 1 out of 2. Because there are 3 even numbers on a dice out of 6 possible even numbers. So when we combine these, and we want to get the Jack of Diamonds and an even number, that means we have to multiply 1 over 52 times 1 over 2. So the probability of getting the Jack of Diamonds and an even number is 1 out of 104. Let's look at the next one. So suppose we want to get the Ace of Hearts, so that one specific card, and a 6 when we draw a card and roll a dice. So let's look at the individual probabilities here. The individual probability of getting the Ace of Hearts, again, is just 1 out of 52, because there's only one Ace of Hearts in a deck of cards, and out of 52 possible outcomes, 52 possible cards. The probability of getting a 6 when we roll the dice is 1 out of 6. There's only one 6 on a dice out of 6 possible numbers. So when we're combining these two things and we want to get the ace of hearts and a 6, we have to multiply these two fractions together. And when we do that, we get 1 over 312. So if we roll a dice and draw a card out of a deck of cards, the probability of getting the ace of hearts and a 6 is 1 out of 312. Now in this experiment where we're rolling a dice and drawing a card out of a deck of cards, there are 312 total possible outcomes, because remember from the last video, to get the total number of possible outcomes of combining two experiments, we take the total outcomes of one times the total outcomes of the other. So to finish off our lesson on probability here, I'm going to get you to answer a couple of questions. So for question number 1, when you roll a dice, what is the probability of getting a 2, a 1 or a 5, and an odd number? For question number 2, when you spin this spinner, what is the probability of getting blue? What is the probability of getting yellow? And finally, what is the probability of getting red or green? And then for question number 3, we're combining these two things. So when you roll the dice and spin that spinner, what is the probability of getting an even number with green? And what is the probability of getting a 1 on the dice and blue on the spinner? If you're able to answer those questions, congratulations, you now have a firm understanding of probability.